Okay, now we're going to be talking about our third method for solving systems equations. That's elimination. Here's your steps for elimination. We're going to line up the equations, and we're going to line them up most of the time in standard form. So we're going to get it in that ax plus by equals c form so that everything lines up. We're going to multiply one or both equations by some number to result in a variable with the same coefficient. So either our x's, we want to be the same, or our y's, so we're going to be the same. From there, we can either add or subtract the equations to eliminate the variables. We're going to solve out the remaining variable, then we're going to substitute to find our other answer, and that'll make more sense as we go through these. Okay, step number one, we're going to line them up. Notice that your x's are lined up, your y's are lined up, your equal signs are lined up, and your numbers. So we got them both in standard form. Now the next step is you're going to try to get your coefficients on either the x's or on the y's to be the same. Notice here my coefficient on my x's are the exact same values. So from there, I can do one of two things. I can take these two equations and I can either add them or I can subtract them. To know which one to do, okay, let's talk about it. If I were to add these two equations, 1x plus 1x gives me 2x's, 7 plus negative 1 gives me 6y's. That's not what I want, because the whole purpose of elimination method, and it's the reason they call it this, is we want to eliminate either x's or y's when we do this. So look what happens when, instead of adding, I subtract these two equations. 1x minus 1x gives me no x's. Those are actually gone now. 7y's minus negative 1y's, 7 minus minus, that'd be plus, that'd be 8y's, is equal to 17 minus, we're subtracting the whole thing, 17 minus negative 7, that'd be 17 plus 7, which is 24. Now look what I have left. I have a very basic one-step equation. To get y by itself, I simply divide by 8 and I get y is 3. So that's half my answer. So anytime you're lined up in standard form, this is much quicker way of finding what your x or y is equal to. Now to find the other one, I've got y to find x. You can plug it in here or you can plug it in here. The second one's probably the simpler of the two. So let's do x minus, take out y, put in 3. Solve what you have left, move the 3 over by adding 3, and you get x is negative 4. So therefore, my answer here is x is negative 4 and y is 3. Done. The second one. Again, we have them lined up. Look at your y values. In this case, you have opposites. You have a positive 2y and a negative 2y. Now, this is actually a little bit easier to deal with when you have opposites, because when you add opposites, we know that we go to 0. 2 and negative 2 added together gives you 0 y's. So we're going to add these two equations together, which gives us a total of 8 x's. Our y's go away. 22 plus 42 gives me 64. And look, you're left with a very basic one-step equation. Divide by 8 and you get x is 8. And once you know that x is 8, you can pick either one of these equations. Let's plug it back in. 3 times 8 plus 2y is 22. Solve the equation. We're going to subtract 24. Gives me 2y is negative 2. Divide by 2 gives me y is negative 1. So your answer, x is 8, y is negative 1. There's where the two lines cross. Number 3. Got a little bit different now. On this one, we don't have the same variables or the same coefficients. We have a 4x, we have a 1x. We have a negative 9 and a positive 5. We want to make these somehow, we want to change them so that we have either the same coefficients or opposite coefficients. So we either want a 4 and a negative 4, or a 4 and a positive 4, or we want a negative 9 and a positive 9, or a positive 5 and a negative 5. We want them to be opposites somehow. So the easiest way of doing this is take the first one and leave it. And let's take our second equation and let's multiply the whole thing. And this is legal. Multiply everything by negative 4. You can do either negative 4 or positive 4 to either make the coefficients the same or opposites. I like to do them to where they're opposites. So we're going to make everything multiply by negative 4. That's now a negative 4x, a negative 20y, and a negative 16. And look what I've done. Now, when I add these two equations together, my x's cancel each other out. So it leaves me with no x's. I now have negative 9 plus negative 20, which is a negative 29y, equals negative 42, and a negative 16 is a negative 58. And when you divide by negative 29 to solve this, you get y is 2. Go back and plug that in, and you can plug it into either one. I'm going to do x plus 5y would be x plus 10 is 4. When you move your 10 over, you get x is negative 6. So your solution is going to be x is negative 6, y is 2. Number 4, you can, again, either make your x coefficients the same or make your y coefficients the same. Since 6 is a multiple of 3, I think it's going to be a little bit easier to change your y's. So I have a negative 6. You can either make this a positive 6 or a negative 6. Again, I like to make them opposites of each other. So I'm going to leave my first equation, 7x minus 6y is negative 53. You can change them both, but you don't have to. I'm going to take my second equation, and in order to make this a positive 6, I'm multiplying everything by negative 2. That's a negative 4x, a positive 6y, a positive 26. Again, everything's lined up. When I add these two equations together, 7 plus negative 4 is 3x. My y's cancel each other out. Negative 53 plus 26 is a negative 27. Left with a simple equation, divide by 3 gives you x is negative 9. Half your answer. Now that you know x is negative 9, you can plug that in here, 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 here. Anywhere that has x's and y's, you can plug it in. We'll plug it into this one. X is negative 9. 2 times negative 9 is negative 18. Minus 3y is negative 13. Let's move our minus 18 by adding 18. Gives me negative 3y is 5. Divide by negative 3. And that gives you that y is equal to positive divided by negative is a negative, and 5/3 does not reduce. So your x value is negative 9. Your y value is negative 5/3. Number 5. Now on this one, there's no easy fix. My x's, my y's, my equals, everything's lined up right, but I have a 5 and a 2. Can't turn a 2 into a 5 very easy. Can't turn a 5 into a 2 very easy. And the same thing with 3 and 7. So the best method here is let's change both. So what I'm going to do, I'm going to take my first equation and I'm going to multiply by 2. And think about what that's going to do. That's going to be a 10x plus a 6y equals a negative 14. And the reason I did that is because now I can take this one, and since now I have a 10x there, I can multiply this by either 5 or negative 5, and that's going to change that to a negative 10x. So pretty much you can multiply this number times this one, and multiply this number or its opposite times that one, and it's going to change it into exactly what you want. So my second equation, again, I'm multiplying by negative 5. That's a negative 10x, a negative 35y, and a negative 15. They're lined up. When I add them, my x's will cancel. You can mark them out if you would like to. And you have 6 plus negative 35, which is a negative 29y, equals negative 14, negative 15 is a negative 29. When you divide by negative 29, it finds out that y is equal to 1. These are simpler equations, so I'd probably plug it in over here instead of over here. So since y is 1, make sure again you plug it into y. We'll plug it into the second one. That gives you 2x plus 7 times 1 is equal to 3. Very basic equation. Subtract 7 gives me 2x is negative 4. Divide by 2 gives me x is negative 2. So x is negative 2, y is equal to 1. That's the point where the two lines cross. Number 6. Again, not a very easy fix here. However, I do notice that both of these can be cleaned up. So that is a rule. If you would like to clean these equations up, let's divide everything by 3. That gives you x minus 3y equals 3. Sometimes that helps you out a little bit. Divide the second equation by 4. It gives you x minus 3y equals 9. So there's something weird happening here because you have x minus 3y on both of them, but then you have different numbers on the other side. So what I'm going to do is I'm going to go through and I'm going to multiply everything in my second equation just to where I can get these to be opposites here. I'm going to multiply everything by negative 1. So my first equation I'm leaving the same. My second equation, I'm multiplying by -1, so it'll be a negative x, a positive 3y, and a negative 9. Now, when I add them together, stuff cancels. And it's odd that actually both the x's and y's cancel. So you have x and negative x are gone, negative 3y and positive y are gone, so there's nothing left on the left side. On the right side, you have 3 minus 9, which is -6. And again, something that a theme, something that's happened several times this course happens again. You're ending up with a false statement. Anytime you have a false statement, then you have no solution. The reason why, going back up here, the reason why these ended up being the same is because these slopes are going to be the same. If you were to actually solve this, however, these numbers over here are different, so they have different y-intercepts. So therefore, that's the reason, since they have the same slope, that's the reason you ended up with no solution. Okay, starting with number 7, now they're not putting them in order for you anymore. So step number 1, you're going to have to put everything where it goes. 5x minus 6y is 3. Let's move these x's over. Negative 2x plus 7y is 8. Now let's change these things to where we can get some stuff to cancel. It doesn't matter if you change x's or y's, we'll change the x's. To change them to where they will cancel, I'm going to take my first equation and I'm going to multiply by 2. That gives me a 10x, a negative 12y, and a 6. In order to get since you have a 10x here, let's make this on the bottom, let's turn this into a negative 10x. So let's multiply that by 5. When you multiply negative 2 times 5, you now have negative 10x. 5 times 7 is a 35y, and 5 times 8 is 40. Now you've got it lined up to where your x's will cancel when you add them together. Negative 12 plus 35, your y's give you 23 y's, and 6 and 40 would be 46. Again, you're left with a basic equation, divide by 23, and you find out that y is 2. Now that you know that y is 2, it doesn't matter where you plug it in. Any of these equations will work, since they all have x's and y's. We'll plug it into this one. It might be the simplest. 7 times 2 is 14 equals 2x plus 8. Subtract the 8 gives you 6 equals 2x, so x would have to be 3. So x is 3, y is 2. That would be the point where the two lines cross. Number 8. Let's get our x's and y's in the right order. So we have 10x, move the 8y's over, be plus 8y's. Let's move the 18 to the other side, be negative 18. My second one, the 9x is good. It's on the right side, but let's move my 5y's by subtracting. Got to move it over here. My 4 moves to the other side by changing it. You can, again, you can change either your x's or your y's. It does not matter. Let me change colors here. We'll change the y's this time just because we've changed the x's every other time. So I need to make these numbers the same. I like when one positive and one's negative. So let's change 8 and 5, find a common multiple, 40. So we're going to take the entire first equation to get a 40 here and multiply by 5. So it'd be 50x plus 40y equals negative 90. I multiplied everything by 5. You need a negative 40 here, so let's multiply. You already have the negative, so let's multiply everything by 8. That'd be a 72x, a negative 40y, and a negative 32. Notice I multiplied by different numbers on each equation. That's fine. Add your x's together because we're going to add so that my y's cancel. 50 and 72 is 122x is equal to negative 122. When you divide by 122, x would be negative 1. Again, replace it in any of the equations that have both x's and y's. We'll do it here maybe. Gives you 4, and then 9 times negative 1 would be a negative 9 equals 5y. 4 minus 9 is a negative 5 is 5y. When you divide by 5, you get y is negative 1. So x is negative 1 and y is negative 1. That's the point where the two lines cross. Okay, next up we're going to solve some application problems, some word problems. Step number 1, we're always going to define our variables. What is x equal? What is y equal? Pretty much what are your unknowns? Step number 2, we're going to set up two equations using the information that we're given. And step number 3, we're just going to solve using substitution, elimination, graphing, whatever method of choice that you have. Number 9 says Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. If books are $1.50, CDs are $5 each, how many did she buy? So our unknowns, we're going to let C equal number of CDs because we don't know how many CDs she bought. And we're going to let B equal number of books. Now we know that she bought a total of CDs, 20 CDs and books. So we know that B plus C is 20. So we got that one in standard form. We also know that books cost $1.50 each. So 1.50 times B tells you how much money she spent on books. CDs are $5 each. So 5 times C tells you how much she spent on CDs. We know that she spent a total of $54.50. So therefore, there's our system. We know that B plus C is 20, and $1.50 B plus $5 times C is equal to the total amount she spent. There's the system we're going to solve. Now, which method do we use? Here's my advice. If you can solve one very easily for B or C, then sometimes substitution is the best method. If they're lined up as they are here, sometimes elimination is the best. However, I've got a 1.50 and a 54.50. I really don't want to worry with, I've got to multiply this by a negative 1.50 and all that. So I might would stay away from elimination here. So let's try some substitution. So let me change colors. On the first equation, you can solve for B or you can solve for C. Does not matter. We'll go ahead and solve for B. The way we're going to solve for B is just simply move the C over. So you have B is equal to 20 minus C. And substitution says we now take that, and in the place of the other equation, in the place of B, we're going to put that. So my other equation turns into $1.50 times B, which we now know is something different, plus 5C is equal to $54.50. Our B value that we're plugging in is 20 minus C. So now we have just a simple linear equation to solve. $1.50 times 20, that'd be 30 minus 1.50 C plus 5C equals 54.50. Combine your like terms, you have 30, a negative 1.5 and a positive 5 gives you a positive 3.50 C equals 54.50. We're going to move the 30 over by subtracting, and that gives you 3.50 C is equal to 24.50. We're going to divide both sides by 3.50, and that tells me that C is equal to 7. Now let's talk about domain and range here, or inputs and outputs. Had you got a C value of like 7.2 there, think about that. C is the number of CDs that you bought. So our C has to be whole numbers. Also, C can't be an integer. It can't be a negative. You can't buy negative CDs. So therefore, if you'd have came up with something in that problem to where C is some crazy number like a decimal, you know that you're wrong somewhere. Okay, now that's the number of CDs we bought. Now to find out how many books we bought, we can plug it back in. I'd probably plug it in here. The number of books is equal to 20 minus the number of CDs. So therefore, the number of books is equal to 20 minus 7, or 13. And you can double check that to see if it works out. Landon babysits and works part-time at a water park over the summer. 1 week, he babysat for 3 hours and worked at the water park for 10 and made $109. The next week, he babysat for 8 and worked at the water park for 12 and made $177. How much does he make per job? So we don't know how much he makes babysitting, so we're going to let B equal babysitting money. And he also works at the water park. We can do a W for water park. So we know that 1 week he babysat for 3 hours. So if we do 3 times the amount of money he earns for babysitting, plus that same week he worked 10 hours at the water park, so 10 times W, and he made that week $109. The next week he babysat for 8 hours, plus he worked for 12 hours at the water park, and he earned $177. Again, there's your system. You can solve it for using substitution or elimination. Since we did substitution on the last one, let's eliminate on this one. Do you get rid of the B's? Do you get rid of the W's? It doesn't matter, because on this one, neither one of them are as easy. You can't just multiply by a single value. So we can go ahead and eliminate the B's. Now, if this were a standardized test and it gives the final question was how much does he make babysitting, then maybe you should eliminate the W's. Or if the last question is how much does he make at the water park, then eliminate the B's and search for the W's. So to eliminate our B's, I'm going to multiply my first equation by 8. Gives me 24 B's plus 80 W's is equal to 872. Since I have 24 B's here, I would really like it if I had negative 24 B's here. So I'm going to take my second one and multiply everything by negative 3. So that would give me the negative 24 I want. Negative 3 would be negative 36W, and that times negative 3 would be a negative 531. Now we're ready for stuff to cancel. My B's cancel completely. 80 minus 36 gives me 44W equals 872 minus 531 is 341. When you divide, you find out that W is equal to 775, which is fine because we're talking about money. So he makes $7.75 at the water park. Now to find out how much he makes babysitting, we got to plug that back in, and that's a pretty nasty decimal to plug in. That's probably our cleanest one to plug it into. So let me change colors. So we now have 3B plus 10 times W would be 77.5 is equal to 109. Subtract the 77.5 and that gives me 3B is equal to, that'd be 31.5. And when you divide by 3, that tells you that B is equal to 10.5, which since we're talking about money, we'll say $10.50. So he makes $10.50 at babysitting. So a little bit more babysitting than he does at the water park. Number 11, last one. Ken has a collection of pennies and nickels that have a value of $1.98. Now, let me show you something, a trick that you can use with money. Instead of working with decimals, if you want to call this, instead of $1.98, we can call it 198 cents. And that way we can say pennies are worth 1 cent and nickels are worth 5 cents. And that's going to make it a little bit easier. So our variables are going to be the number of pennies we have and the number of nickels. Before we even read the rest of the problem, we know that's going to be what we're missing. The number of pennies he has is 5 less than twice the number of nickels. How many of each coin does Ken have? So your unknowns are your P's and your N's. So he has a collection. The collection adds up to $1.98. So each penny he has is worth 1 cent. So we do 1 times P plus 5 times N. Each nickel that he has is worth 5 cents. Together, they're worth 198 cents. And again, notice I don't have to worry with decimal points if I solve it that way. Okay, the next line says the number of pennies he has is, see the is, 5 less than twice the number of nickels. So twice the number of nickels, 5 less than that. Again, the number of pennies he has is 5 less than twice the number of nickels he has. So here's my 2 equations now. I can take that 1 off if I'd like to. And this is very, very set up for substitution because your second equation already has P solved for. So since you know what P is equal to, in the other equation, we take out this P and we put in what it's equal to. So substitution-wise, your first equation is now 2n minus 5. Take out the P, put in 2n minus 5, plus 5n is equal to 198. Now, these parentheses are actually unnecessary because there's no number out front. There's nothing being raised to a power or anything. Combine your like terms gives you 7n minus 5 is 198. Move minus 5 over by adding gives you 7n is equal to 203. So therefore, dividing by 7 tells you that n would have to be 29. And now that you know that n is equal to 29, probably right here would be the best place to plug it back in. The number of pennies that you have is 2 times 29 minus 5. That's 58 minus 5, which would be 53 pennies. And you can double check that to see if it checks out right.